To find the area of any regular polygon, we're going to do so by breaking the polygon into triangles. So if you look at example A, we have a hexagon. And if you see, we have a center point to the end of the polygon. And what we can do is break this into triangles by extending that center point here and here. So we can find the area of this triangle. And if you look, we have a total of 6 triangles within the hexagon. So if we can just find the area of this one triangle and multiply it by 6, that'll give us the area of the entire polygon. So let's start by figuring out the area of the triangle here. So if you recall, the area of a triangle is 1/2 the base times the height, where the base and the height are perpendicular to each other. So this would be a right angle. Now the base that they give us, they've only given us half of it. So if this is a regular polygon, we are going to have an isosceles triangle. So we can say that this entire base is 6. So 1/2 of 6. And the height of this polygon, as we can see, is from the center to the end point here, which is 4. So the area of just this one triangle is going to be 1/2 of 24, which is 12. That gives us the area of this triangle. And as we said, there are 1, 2, 3, 4, 5, 6 triangles that exist within this regular polygon. So we can take the area, which is 12 square centimeters, and multiply it by how many triangles exist within the polygon, which is 6. So we get 6 times 12, which gives us 72 units squared, or in this case, our units are centimeters. Alright, so I'd like for you to pause the video and try example B on your own and to see if you get what I get. Okay, and you should have calculated 96 square centimeters. Well, there's actually an easier way to calculate the area of a regular polygon. If you have a regular polygon, first we need to identify something called the apothem. The apothem is just like a radius in a circle. It is a segment that connects the center of a polygon to the opposite side of the polygon. It's going to be the same distance no matter where we draw it in the polygon. The apothem is going to play an important role in our formula to find the area for regular polygons. When we talk about the apothem in our formula, it's going to be represented by a little a. When we refer to the perimeter of the polygon, we're talking about the sum of all the sides of the polygon. So if I know one side, let's say this is 10, then I would take that side and multiply by how many sides there are. So in this case, the perimeter would be 10 times 1, 2, 3, 4, 5, 50. When we give the formula for the area of a regular polygon, perimeter will be represented by a big P. Now, the area for any regular polygon, and remember it has to be regular, that means that all the sides and angles will be congruent. To find the area of a regular polygon, we take 1/2 of the apothem, little a, times the perimeter of the polygon, big P. Now formulas seem very easy, and it seems like you're just going to have to plug and chug into the formula to find the area. But in this unit, you're going to have to use previous knowledge in order to figure out the length of the apothem and to figure out the angle measures in order to figure out the length of the apothem. So we're going to have to use trig in this chapter. So just a little refresher course, SOHCAHTOA for trig. We place a little point on the angle of reference that we're going to use. We identify the sides in relationship to that angle. So 36 opposite 36 is x, and adjacent to 36 is 7. The trig function, which has an O and an A in it, is the tangent function. So we set up the equation. Tangent of an angle is equal to the opposite side over the adjacent side. So the angle measure, so tangent of my angle measure, which is 36, equals the opposite side, which is x, over the adjacent side, which is 7. I'm going to calculate the value of tangent of 36, and we just want to make sure that we are in degree mode in our calculators. So the tangent of 36, 4 digits, gives me 0.7265. So 0.7265 equals x over 7, where I'm going to cross multiply. So I get x equals 7 times 0.7265, which is a total of, to the nearest tens place, 5.1. Now sometimes it won't be a side length that you're looking for, it might be an angle measure. So we do the same thing. We put a little dot where the angle measure is. We label the sides according to what they are in relationship to the angle. So 19 is opposite x and 22 is adjacent to x. So once again, the tangent of your angle is equal to the opposite side over the adjacent side. And in this case, the angle measure is what we're looking for. So if you're looking for an angle measure, you're using the inverse function. So all you do is find the inverse function of tangent by pressing second tangent, and that represents the degree of the angle. And then the ratio, 19 divided by 22. So the angle measure is going to be 40.8, and when we're dealing with angle measures, we usually round up to the nearest whole number. So x is actually going to be 41 degrees. Alright, I would like for you to pause the video, label the sides, set up your trigonometric ratio, and solve for the value of x in number 3. And you should have gotten that x is 3.1. If you didn't, raise your hand or ask a neighbor. The next skill you're going to have to know from previous chapters is to find one of the interior angles of a regular polygon. Well, if you remember, if I wanted to find all of the interior angles, I would use the formula 180n minus 360, where n is the number of sides. So in this polygon, I have 1, 2, 3, 4, 5 sides. So I would take 180 times 5, which is 900, and subtract 360, which is 540. 540 represents all of the angle measures of the regular pentagon. Now I need to figure out what just one of them is. So this angle right here, maybe. Then I would divide the total angle measures by the number of sides. So 540 divided by 5 gives me a total of 108 degrees for each angle. So I can say this angle right here is 108 degrees. Alright, so I'd like for you to pause the video and try number 5 and number 6 on your own to see if you get what I get. Okay, for our regular hexagon we have 120 degrees, and for our regular heptagon we have 128.6 degrees for each angle. Okay, so now let's get back to the area of a regular polygon. This is going to be a multi-step process, and not all the steps will apply. It just depends on how much information you were given for the polygon. The first step is to find one of the interior angle measures. So to find this angle measure right here. So exactly as you did in the previous examples, figure out what this angle measure is here. Pause the video to see if you get what I get. So you should have gotten that this angle measure here is 135, which is the same for all of these angle measures in here. Now if you have an apothem and then you have another segment down here, that segment is going to create an isosceles triangle. It's also going to cut the angle directly in half. So we need to figure out what this angle here is. So we're going to divide 135 by 2 to get this angle measure here. So we get right here is equivalent to 67.5 degrees. Now the reason we did this was so that we can find the height or the apothem of the polygon. So what we have here is a right triangle. We're looking for the height. We know that this whole thing is 10 inches, so this little piece is 5. Right here is 5. And we're given 67.5 degrees. So we're going to have to use trig to find the value of x here. So I'd like for you to pause the video and using your SOHCAHTOA, Figure out what the value of x is to the nearest tenths place. Okay, you should have gotten that x, the apothem, is equivalent to 12.1. Okay, now step 3 is to find the side length of the side of the polygon. Well, this time it's really easy. They already gave it to us. It's 10. 10 inches is the side length of the regular polygon. Now, if we were not given the side length, so let's say we were given the apothem and we were looking for the side length, once again we would use trig again, but that would only give us half of the side length. So we'd have to multiply by 2 to find the entire side length. But we have the entire side length, which is 10. Now we're going to substitute all of our values into the equation 1/2 the apothem times the perimeter. Well, the apothem we found was 12.1. That's right here. The perimeter is going to be the side length, 10, times how many sides there are, which is 1, 2, 3, 4, 5, 6, 7, 8. So 10 times 8, which is 80, gives us our perimeter. So to substitute the values into the equation, 1/2 apothem times perimeter gives us an area of 964 inches squared. Okay, so example number 1. My first step is to figure out what the angle measure is here. So we first need to figure out what the whole angle measure is and then cut it in half. Well, we have 1, 2, 3, 4, 5, 6 sides. So we figure out that we have 180 n minus 360, where n is 6. So 180 times 6 minus 360 gives us 720 degrees for all of the angle measures. How many degrees is just the one angle measure? So how was that those 6 angles split evenly amongst 720 degrees? So 720 degrees split evenly amongst 6 angles gives us a total of 120 degrees per angle. So each angle is 120 degrees. Now this angle here has been cut in half, so it's going to be a 60-degree angle. So now we have a right triangle where one angle is 60, and we are already given the apothem, which is 5 square root of 3. So now we need to find this side right here. Well, as you can see, we have a 30, 60, 90 triangle. The side opposite the 60 is t square root of 3. And we're looking for the side opposite 30, which is just t. Well, if 5 square root of 3 is t square root of 3, then clearly t must be 5. So we set t equal to 5, which means that this side here is 5. So if this side is 5, then the whole length of the side of the polygon is 5 plus 5, which is 10. So we have a side length of 10, we have an apothem of 5 square root of 3, and we have the number of sides as 6. So 1/2 the apothem times the perimeter of the polygon gives us the area for this polygon. So 1/2 the apothem, which is 5 square root of 3, times the perimeter, which is 10 times how many sides there are, which is 6, gives us 1/2 5 square root of 3 times 60. And we can substitute all these values into our calculator. 0.5 times the 5 times the square root of 3 times 60 gives us an area of 259.8 centimeters squared. Alright, number 2, you're really lucky because they already gave us a side length. They gave us the apothem, so you don't even need to find the angle measure. You just need to go ahead and substitute your values into the equation. Okay, pause the video and see if you get what I get. And I got a total of 204.4 square meters.